Once ISIS has been deployed over the entire backbone, we can now set OSPF's admin distance above that of ISIS. And we do this for all routers across the backbone. There's no real sequence required. We can do any router as we wish, working across the backbone. The main thing is not to forget any. For example, all we need to do is log into the router, go to the OSPF process, and simply change the distance to be higher than that of ISIS. In Cisco IOS, OSPF distance is 110, ISIS distance is 115. So we could make OSPF's admin distance 120. What this will do is all ISIS paths learned by the router will now take priority over the OSPF paths for both IPv4 and IPv6. Both protocols will carry all the prefixes. So that, again, doing this deployment, there's no real structure or sequence needed. Just make sure that all routers across the backbone have this admin distance changed. Once the task is completed, ISIS should now be responsible for all the interior routing. And there should be no prefixes left in the global routing table caused by OSPF. If there are, check what they are and what caused them. The usual causes would be forgotten passive interfaces for ISIS and forgotten active adjacencies. So we now take the opportunity to look around the network on all the routers, looking for remnants in the global RIB that are caused by OSPF. And we can check adjacencies across the backbone using the show IP OSPF neighbor and show ISIS neighbor commands. Each protocol should have the same number of adjacencies and the same number on the same routers. If not, fix the problem. The end result of tidying up should mean that there are no more prefixes left in the global RIB caused by OSPF, and we have a successful deployment of ISIS. Once this has been done, we can remove OSPF from the entire backbone. In Cisco IOS, you simply log into the router, and no router OSPF and no IPv6 router OSPF will remove all the OSPF configurations. Notice on some of the older versions of iOS, you may also need to go to each interface and remove the OSPF metric, link type, and any authentication configurations. The newer versions clean this up very well. In iOS XR, the no router OSPF and no router OSPF v3 commands perform a clean removal of the protocol. Once this has been done, we should confirm that ISIS is functioning normally, so verify the IBGP sessions. They should not have been affected by the entire migration process. Verify the next hop values. The adjacency should be known in ISIS. Verify customer and external access. Hopefully no customers would have phoned in complaining. Hopefully the internet would have carried on working through the entire duration of the project. And your task is now complete. So migration from OSPF v2 and OSPF v3 to ISIS is straightforward. But you need a plan. It's important to make a plan first, how we've described it in this sequence. And follow this plan while we're doing the migration. Now, the migration could be carried out at any time. It doesn't affect anything on the network. But of course, most network operators would be doing this for the one and only time. So using planned maintenance slots is strongly recommended. And once we've done this, we're now running a single multi-address family IGP to support both IPv4 and IPv6. Just as a footnote, migrating from ISIS to OSPF, first off, I don't know if anybody would want to do that. But it is the reverse of the described process. The admin distance is the key. If you're using another routing protocol, for example Cisco's EIGRP, and you want to move to ISIS, again, the same procedures as described here should be followed. But note that EIGRP's administrative distance is either 90 or 170, depending on the prefix origin. So you would need to be careful setting the ISIS admin distance appropriately. Basically make the admin distance higher than 170 when ISIS is being first deployed.